this is the second part of the video about radicals, and this time we are going to discuss on multiplication of radicals as well as division and rationalizing the denominator of radicals. We have here the first multiplication, and these are the following important reminders when we are going to multiply radicals. First is the product of radicals with different indices and the same radicand. We have here transform the radicals to powers with rational exponents. These are actually the steps or the suggested steps on how we can get the product of radicals with different indices and the same radicand. Next is multiply the powers by applying the rule of x to the power of n times x to the power of n, which is equals to x m plus n, or x raised to the power of n plus n. Then we write the product as a single radical and we simplify the resulting radical if necessary. So again, it's very important to simplify the radicals if you can still simplify it. But of course, if it's not anymore possible, then let it stay as is. Another is, these are also the steps, the following steps on how we can get the product of radicals with different indices and different radicands. We have transform the radicals to powers with the rational exponents. So it's very important to rewrite it into this form. And then change the rational exponent into similar fractions. So again, applying the similar fractions, and then we write the product as a single radical, and of course simplify again if necessary. So these are the important tips that we have to remember in multiplying radicals. Let me show you how to solve some problems of multiplication. First is the product of 6 square root of 3 times 4 square root of 15. In solving this problem, you will just simply get the product of the whole numbers, which are 6 and 4. And of course, you will also get the product of 3 and 15 because they are both square roots. Okay. Therefore, what we will have here is 24 times the product of 45. And since 45 has a perfect square factor, which is 9, we can still simplify that, and that will become 3 square root of 5. And of course, this 3 will be multiplied to 24. Therefore, your final answer will be 72 times square root of 5, or 72 square root of 5. Next is, this time we are going to multiply the product of the same radicand but different indices. Okay? And in solving for this, of course, you will have to write this in fractional exponent. Therefore, you have 2 raised to the power of 1/3 times 2 raised to the power of 1/2, and then get the LCD of 1/3 and 1/2, which is 6. 3 and 2 is 6, so 6 divided by 3 is 2, times 1 is 2. That means 2 6 is equivalent to 1/3. Plus, we add because that's the law of exponent. When we are going to multiply the base, we add the exponent. And 6 divided by 2 is 3, times 1 is 3, which is also equivalent to 3 6. Okay, and then add, we have 5 6 as the exponent, and therefore, when you are going to write that in radical form, that's the 6th root of 2 to the power of 5, which is equals to the 6th root also of 32, because 2 to the power of 5 is 32. So if you want to have the simplified form of the product, is this one. Okay, and then we have also the product of different radicand and different indices. The same step, you are going to write the exponential form of each factor, okay? And then you have to make them into similar fractions. Therefore, of course, the LCD is 6. And based from the given, from the previous example, 6 divided by 3 is 2 times 1. So 2 6 is equivalent to 1/3. And of course, 3 6 is equivalent to 1/2. And then, you write them in radical. So 6th root of 2 squared times the 6th root of 3 cubed, which is, of course, when you combine it, that's the 6th root of 2 squared times 3 cubed. And 2 squared is 4, 3 cubed is 27, therefore its final is the 6th root of 108. Okay, so this one is the product if we are going to multiply different indices and different radicands. And here the same radicand but different indices. And of course, if we will have here a combination of all, we are going to apply here the distributive property. So the cube root of 4 times the cube root of 2 plus the cube root of 4 times the cube root of 3. Okay, and then of course cube root, therefore you get the cube root of 4 times 2, which is 8, and the cube root of 4 times 3, which is 12. And take note, the cube root of 8 is 2, it's a whole number, then plus the cube root of 12. You cannot anymore simplify that. So therefore, this will be the final answer. So for this one here, okay, and then for this one and this. These are the sample solutions in solving the product of different cases on radicals. Let me give you some sample problems also on how to solve if we are going to multiply binomials containing one radical and the whole number and the other also, for example, like this. So how are we going to get the product for this? Okay, of course, you are going to apply the FOIL method. Okay, so the FOIL method, under the FOIL method, you get the square root of 2 times square root of 2. So this one. Okay, and then for the outer, we have negative 4, this one and this, both outside. So we have negative 4 square root of 2, and then the inside is positive 3 square root of 2, and then the last terms we have, let me use this color, we have negative 12. Okay, and of course, when you are going to simplify, we have here this one, square root of 2 times square root of 2, that's square root of 4, which is still equals to 2, right? And we have here 2. Okay, square root of 2 times square root of 2 is square root of 4, which is equals to 2. And then this one, they are similar, so negative 4 plus 3, and then square root of 2, and then minus 12. Of course, you simplify this. So that's negative 4 plus 3, that is negative 1. And negative 1 square root of 2, or just simply negative square root of 2, minus 12. Therefore, we have here 2 minus 12, and then minus square root of 2, therefore you will have here negative 10 minus square root of 2. Okay, like here, minus square root of 2. So this is the product of this given problem. Okay, this one. Okay, and that's also applicable, for example, if you are going to get the square of the binomial, like square root of 2 plus square root of 5 squared. So still we're going to apply here the FOIL method, or you can also apply the rule of squaring binomials, which is you square the first term, then plus twice the product of the first and the second term, and of course you square the last term. Okay, that's the shortcut of squaring the binomial. So of course, the square of square root of 2 is of course 2, and 2 times the product of this, that's 2 square root of 10, and then the square root of 5 is also 5. So therefore, you will have here the final answer 2 plus 5, which is 7, plus 2 square root of 10. So this will be the final answer for this given problem. Okay? Now let's proceed to the division of radicals. We have here the first problem is you get to find the quotient of 4 times the square root of 8x to the power of 5 and over 2 square root of 2x squared. Okay, so for the quotient rule for radicals, of course we have here 4 divided by 2, we separate the whole numbers, and then we get the square root of 8x to the power of 5 over 2x to the power of 2. Applying the law of radicals here, so of course you divide that, and then the square root, this will be 8 divided by 2, which is 4. And then of course the law of exponent, when we divide is we subtract their exponents, of 5 minus 2 is 3. Okay, and then you factor out this to 1 with the perfect square factor, the greatest perfect square factor, and the other factor. So of course you get the square root of 4 is already a perfect square, 4, and then of course x cubed, we can have here x squared and x. Okay, therefore you get 2, then square root of 4x squared times square root of x. And of course we have here 2 times this one is 2x times square root of x. Therefore your final answer here is 4x square root of x. Okay, and then the other one we have is this. Again, we apply the quotient rule. We have here is we have here 9x cubed over 3x. Okay, and then you get the cube root of 16x to the power of 5 over 2x squared. So again, we simplify this. Of course, 9 divided by 3 is 3. And then x squared divided by x is just x. So we have 3x. And then the cube root, 16 divided by 2 is 8. And 5 minus 2 is 3. So it's x cubed. And of course, you get the perfect cube. Since 8 and x cubed are perfect cube, which is cube root of 8 is 2, and cube root of x cubed is of course x. So therefore, we have 3x times 2x. Therefore, our final answer here is 6x squared. Okay, those are basic examples or steps in solving for division of radicals. And the last part of our video is about rationalizing the denominator. And this applies if there is a radical in the denominator, or we call it irrational numbers in the denominator. And of course, to rationalize the denominator of a certain radical expression is of course to multiply the numerator and denominator by an expression that will give an nth root of an nth power in the denominator. Okay, so we have here, for example, 7 over square root of 5. This looks simple, but actually that's not in lowest term or simplified form, because you can see here an irrational number or a radical number in the denominator. And to rationalize that is we have to multiply this denominator by 1, and this 1 whole must be written in fraction form such that it will not affect the value of the original expression. And of course, we have to make this into a number or a whole number. And to do that is we have to multiply this by a certain number so that it will become a perfect square, so that we can immediately extract its perfect root. And of course, we can have here square root of 5. And of course, that's square root of 5. Therefore, we will get 7 square root of 5 over 5 times 5 is 25. Therefore, the square root of 25 is 5. There. This is your number or the rationalized denominator already. Another example we have is this one. If it's written in one of the factor is in radical form, okay, therefore what we have to do here, if you have read your module, is we are going to multiply it by its conjugate. And of course, the conjugate of this is square root of 2 minus 1. Right? Okay, and you apply the distributive property all over this one. When we multiply conjugates, we will just simply get the square of the first terms minus the square of the second terms. That's how we are going to get the product of conjugates. Therefore, we do distributive property all over this one. The square and the square of 2 is 2 minus 1. So therefore, we have 3 square root of 2 minus 3 all over 1, or just simply 3 square root of 2 minus 3. So if the denominator is 1, you can just have this as your final answer. Okay, and the last we have is we get the product of, the quotient of this. And of course, we cannot do the final answer here as that because we have the radicals in the denominator. Again, we are going to multiply the numerator and denominator by the conjugate of 6 square root of 2 minus square root of 5. Therefore, 6 square root of 2 plus square root of 5, that will be the conjugate of this. Okay. And then since you are multiplying the same, you can just simply write that as 6 square root of 2 plus square root of 5 squared all over. When you multiply conjugates, you get the square of these terms minus the square of the other. Okay, and then of course applying the square of the binomial, you get the square of the first term plus the product, twice the product of this and the second term, and of course you square the second term divided by this 6. Take note that 6 square root of 2, when you square that, is actually this one. So that's equals to 36 times 2, which is 72. Okay, so that's why what we will get here is 72 minus 5, because square root of 5 squared is 5. Okay, therefore this one again is 72 plus this one. When you multiply, that's 2 times 6 is 12, and then 2 times 5 is 10, square root of 10, plus this one is 5. All over 72 minus 5, which is 67. And finalize, you have here 72 plus 5 is 77 plus 12, square root of 10, all over 67. Okay, so there. This is our final answer. Okay, that's how we are going to rationalize the denominator. You cannot cancel out this one and this because of course they have different numerals. Okay, the rest. So you can only cancel out once you can say common. Like for example, this is divisible by 2, divisible by 2, and divisible by 2. That's the time you can cancel out or reduce. But if not, then as is. Okay, so that would be all for our video, and thank you everyone. God bless and stay safe.